Okay, students, we're going to do a second Thevenin equivalent circuit. As you can see, the load is the 420 ohms with negative 90 capacitor. So I'm going to draw the Thevenin equivalent circuit down here. And then ZTH. And then the load. Since the first thing we have to do is remove the load, I'm going to make this the 420 ohms at an angle of negative 90, and that's the load. Okay, so we can redraw this, 25 at 10, taking a look at this without the load. 400, 6, so we have 400 ohms here. 600 at an angle of 90 because it's an inductor. We have the resistor and we have another source. And then we have A to B. And this is 10 at 15 and this is 680 ohms. Okay, so basically what we need to do is get voltage A to B or A to B. So either way, we need to get the voltages here. So we can use the voltage divider rule because all we have is a series circuit. Because this is open, there's nothing going to be, going through that. So we have 25 at an angle of 10 times 600 at an angle of 90 divided by the total, which is 400 ohms plus 600 ohms at an angle of 90. And that's to get the voltage across this inductor. Okay, so we have 25 at an angle of 10 times 600 ohms at an angle of 90 divided by the total, which is 400 ohms plus 600 at an angle of 90. So the voltage across that 600, if you get that, just press the F to D button and it'll give it to you, is 20.80 volts at an angle of 43.69. So that's the voltage across here. So now we can actually get voltage A to B because we know that this is 20.80 at an angle of 43.69. There's no voltage going through that 680 ohm resistor. However, there is a source here. So voltage A to B is plus 10 at an angle of 15. Oh wait, we have plus to minus. Plus 20.80 at an angle of 43.69. So we can add them together to get VTH equals 10 at an angle of 15 plus 20.80 at an angle of 43.69. When we add them up, I'm going to do 10 at an angle of 15 plus 20.80 at an angle of 43.69. And my VTH is 29.96 volts at an angle of 34.47 because there's a 9 after the 6. So my VTH for the Thevenin equivalent circuit is 29.96 volts at an angle of 34.47. So the last thing we need to get is ZTH for the Thevenin equivalent circuit. So we can redraw this. Remember, voltages get shorted, currents are open. We only have two voltage sources, so it'll be as such. You draw the circuit again. Oh, there we go. This will be shorted. This is 400 ohms, 600 at an angle of 90. Then we have 680 ohms. We had a battery here, and then we have A to B. Remember, you have to look back where the source was, or the load. So this is either a pretend battery or a look back method, whatever. What's going on in this circuit? That's right. You have this in parallel with this. Once we get that answer, you would add this 680 ohm resistor. So that would be ZTH. So 400 in parallel with 600 at an angle of 90 equals, let's put it in our calculator, 400 shift reciprocal, that's 1 divided by, plus 600 at an angle of 90, shift reciprocal equals 1 more shift reciprocal. So we have 332.82 ohms at an angle of 3369. So that would go here. So ZTH would be 332.82 ohms at an angle of 3369 plus 680 ohms. That would be our ZTH. So we can add that up. We can just say plus 680. So ZTH is 974.57, because after the 6 there's an 8, at an angle of 10.92. So that's our ZTH. So we can put that in our Thevenin equivalent circuit. 974.57 at an angle of 10.92. Last but not least, now that we have our Thevenin equivalent circuit here, right, this is it, is we're going to get the voltage across the load within the Thevenin equivalent circuit. So we're going to use the voltage divider rule. So it would be 29.96 at an angle of 34.47 times 420 at an angle of negative 90 divided by, both of them added together, 974.57 at an angle of 10.92 plus 420 at an angle of negative 90. So that's using the voltage divider rule to get the voltage across the load. So we're seeing VRL as 12.77 volts at an angle of negative 41.71. And this is our answer. This is what we're looking for within the Thevenin equivalent circuit. All right, stay safe.